session on virtual power plants and power system flexibility at India Smart Utility Week 2024. May I pleasure to invite chair for this session, Mr. Ghanshyam Prasad. He is a chairperson at Central Electricity Authority. Welcome, sir. May I pleasure to invite moderator for this session, Mr. Murali Baggu. He is a program manager for grid integration at NREL. Welcome, sir. May I also invite panelists for this session, starting with Mr. Vishwajeet Singh, Senior Manager, AutoGrid. Welcome, sir. May I also invite S.K. Soonee. He is a former CEO at Grid Controller of India. Welcome, sir. May I also invite Mr. Abhishek Vashistha. He is a Deputy General Manager for Engineering at BYPL. Welcome, sir. I would like to invite Mr. Ankur Sharma. He is a founder and CEO at Flock Energy. Welcome, sir. May I invite Ms. Meenakshi Vashist. She is a co-founder and CEO at TekUncorked. Welcome, ma'am. She will be joining shortly with us. I would like to invite Mr. Devanand Pallikuth. He is a Chief PSCC at Tata Power Company Limited. Welcome, sir. May I invite Mr. Arindam Maitra. He is a Vice President for Energy Innovation and Grid Services at L&T Digital Energy Solutions. Welcome, sir. I am handing over this session to Mr. Murali to take this session forward. Thank you, sir.
Thank you very much, Balu. It's an honor and privilege to really moderate this session. I'm sure virtual power plants as a concept have been there for quite some time, but I think we are in an unparalleled era in which there is a lot of potential behind the meter that can be tapped into, and what is the best way to do that is something I'm envisioning we'll have a reasonable discussion on in this particular session. I do have a few slides to set the stage here, and then I'll pass it on to our Honorable Chair to really talk, give his comments. Again, the idea of this particular presentation is to bring in some background at what we do at National Renewable Energy Laboratory in this space to set the stage. And again, not selling any solution here, but really see what different areas we are going to talk and look at in this particular area. One of the biggest motivation, as I was mentioning, right, the supply and demand equation has been the two sides of the balance for quite some time, but a lot of activity on the supply side. But most recently, over the past decade, we have seen a lot of more activity on the demand side. And this is in due to a lot of renewable energy integration that is happening on the demand side, certainly creating a lot of variability in the system, but at the same time also creating an opportunity to balance it out as much as possible. And that's what we are looking at. I think effectively this is also deriving to what we call fewer conventional dispatchable generation. We need to really look at system inertia and see how we can get these things from the distribution side. So one of the setting stages that I want to really think about is, yes, there is a lot of potential on the distribution side, but how are we really tapping it to help on the transmission needs of the system is one thing that I want us to think through and talk about as much as possible during the session. We looked at architectures which are more federated in nature. I think that's the fast terms that you see, federated architecture for secure and transactive distribution system management, and also the DSO construct, which is evolving in many countries and shows some promise in terms of enabling these things going forward. One thing I want to mention certainly is the picture on the right actually gives a perspective of this is as we look at this DSO construct and network aware optimization techniques, we need to be an all-inclusive approach which can look at aggregators, transactive markets, and other direct control mechanisms, if so possible, and really come up with right solutions. I'm sure we have a lot of people on the stage here who are going to give the perspective from the solution side of things, and we'll probably hear on the utilities and regulator side of the things as needed. I will leave with this last two slides. Again, example of running VPP in the United States, Sunrun with ISO New England and Home Connect in California, very successful VPP programs where people interact with directly with the wholesale market and get compensation. So again, a pilot that is really working on, this is what we call wholesale VPP, and we're also looking at retail VPP models, and there are a few things like bring your own device, or things like bigger DERMS aggregation, and utility scale partnership for Hawaii and others to really provide grid services, and what I call solar or Sunrun VPPs for Puerto Rico and others. So there are some of the wholesale and retail VPPs, and hopefully we'll actually have discussion on both sides here. On the right, exhaustive list of use cases. I'm using exhaustive implicitly here just because there is a lot we can do, but how do we do is important thing, and what are the challenges to get there that we're looking at. I'm also looking at an angle within US, which is what we call energy justice. This is not only for affluent customers but we need to really look at how we can get to all pockets of loads that we are looking, and how can we integrate it. I'll leave with this last slide and then open it up for chair's comments. These are a rehash of the 10 questions that you see on the session here. I'll probably keep a close note of all our presentations and see if we are missing anything, then we'll probably open up for discussions, try to talk about the questions that are not really addressed during the presentations. I'll strongly recommend our session chair and panelists to stick to 7 minutes if possible. I mean, given that this is the last session of the day, let's try to see if we can get it done in time with some productful discussion. With that, please, Chair, if you can provide our comments, that will be great. Ghanshyam, Prasad.
Yeah, thank you for the setting the tone on the very important topic of the day today, even though it's the last session. But I think it is one of the most important idea which is being floated around, and this has a huge amount of potential. In fact, after attending the inaugural session, I'm coming especially for this particular session just to have better ideas about this and how really we can promote in India. Because ultimately the solution lies in the hands of the consumers. And if I'm really able to tap, in fact, in the inaugural also I said the same thing, unless each and every consumer starts participating in the aim to achieve the energy transition, probably the things globally will not happen. In whatever manner, it has to either supporting the DISCOMs or supporting the GENCOs, supporting in whatever manner that is there. And the most important to my mind comes as that he has to become a prosumer. That means he has to consume as well as generate renewables. And the day it starts happening, he starts supporting himself, and he also starts supporting to the others who are not able to do it. Probably that's where we stand as of now, which will avoid a huge amount of capex in the different major infrastructure, but at the same time, this will also ensure that the things starts happening, because small things will definitely lead to a much larger things. Ultimately, what we are aiming is, we want the consumption of electricity to go green. That's the ultimate requirement. And if I am able to really facilitate this, I think we are there. So I'll not talk much. I'll take even less than 7 minutes, what have been allotted to me. I would like to hear first from all the experts who are sitting in my left and right. So maybe we can start with Mr. Soonee.
Thank you very much. Thank you, ISGF. Thank you, Chair, that you have come after inaugural only for this. Puts onus on the panelists, you being the policy maker, to convince you that we need VPP. And I will try to do that. Okay. You have already said it's a very important topic. I made 100-slide presentation and then left it. I said it's not worth it. So, bit of a history. I did some research. ChatGPT, Google, and all the records which I have on alert. The first I heard of virtual power plant was in early 2000. And ever since then, must be having 200 to 300 good literature on virtual power plant. Why did it come? How it changed? Why were they conceptualized? And why they have become more important in view of RE is all we have heard, and I am sure other panelists will cover. So, I being a practitioner, if you bring any concept to me, and I know that Mr. Ghanshyam Prasad too is a very tough taskmaster, first thing I would say, show me the legal side, the regulatory side, show me how you will do accounting and settlement in a dispute-free fashion. Show me that how will the gaming be avoided. And last, integrity and probity of the whole system has to be proven. Because grid is not full of angels. You have rogue players, and we got to take care of that. That is the first thing which we test, and if that's fine, then I tell you things are very easy. I have gone to regulators, I have gone to Mr. Ghanshyam Prasad as a policymaker that, look, this is good for the country, and this is all we have tested. You have always their blessings, and many, many changes have been brought in. So in this VPP, we also need to address those things. Rest all add-ons will come. There is no issues at all. First, if the basic is put into place, then it will come. That's my view on this. Now, very quickly, 2 or 3, you have 7 minutes, no? So how much I have? There should be a clock, you know. So I'll tell you, when our Bangladesh friend was here, he is not seen. Okay. So I went to Dhaka. The operator said he has read every regulation of India. And on the screen, he knows about all the power stations. There is 1,000 megawatt link, and to him, that 1,000 megawatt is a generator, which never trips, which he can fluctuate the way he wants it. What a beautiful 1,000 megawatt generator he has got. Unimaginable if you would have to put a generator. 13 plants, he has done the aggregation. I found that I never realized being in India that, oh, here is a plant, virtual power plant, which Bangladesh is benefiting like anything, a practical example. So when I asked that operator, tell me where is Murali, where is Adri, he said, I don't know, all things is through screen only. That was such a music to my ear that here is the implementation of it. I understand that it's a portfolio, it's not exactly VPP in the definition, but who cares about the definition? If it works, that's it. So I would come to quickly the other points. Whenever I hear VPP, that V for virtual, besides that a vector comes in my mind. Energy vector is the issue. Because gone are those days where we will have one kind of a plant. So how do we handle those vectors? That's one thing. The other thing is, if you put one instrument, then players will innovate. They will find out what more can be done. But we need to first allow them to do that. We recently had our IGC 2023, and we were working for the last 2 years. VPP came rounds and rounds of discussion on VPP, but somehow it couldn't find a place in grid code. Now, I have a mixed feeling for that, oh, we should have come. But if it would have come, then the question is, how do we ensure that everything is settled? How do we convince the regulator that everything is there? So that's a half-finished work which we have. We have heard about balanced responsible parties. We don't have a very clear balanced responsible parties. We have traders, but we don't have aggregators. It's a shade of trader, but slightly different than pure trading. So the issue to, and then federated, which our moderator very nicely explained. India is fully federated. We have a solid base as far as federated things are concerned. DSO, it has found place in all our documents about DSO. So we are ready in that respect also. But what is missing? Then why are we not able to implement VPP very quickly? To my understanding, it's like this. VPP will be normally not one-to-one. It will be one to many and many to many. That's the challenge. Once it is many to many, it becomes a collective transaction. Presently, our mindset is that collective transaction only goes through power exchange, which has to change. Collective transaction can be by anyone. He may not know the price, but still he can say the group of people have agreed to sell and buy, and from a group of people to sell, provided metering, accounting, billing, settlement, everything is pakka, and that's doable because we do it for collective transactions. Losses, transmission, all the complexities, we are very conversant with it. So the bottom line is we need a collective transactions other than power exchange to be introduced in our suitable regulations and the code with proper arrangements for accounting and settlement. Rest, players will innovate and find out how they can do it. I think I have not much to say, but few things. Benefits are huge. Technical virtual power plant, commercial virtual power plant, nitty-gritties, DERs, plus demand response. I can see many, many combinations coming up, provided we open up that collective buy, collective sell. If they come to an operator for scheduling, it should be possible. Price, I need not know the price. That's for them to settle. And if that can be done, then we have got it. There are benefits for TSOs, benefits for policymakers. And I again spend a couple of minutes, because where will I get captive chairperson CA to listen to this? That if we have to scale up energy market, if we have to scale up prosumers, and if we have to come from the bottom, the prosumer which you talked about, we need VPPs, we need aggregators, and then things will set in place. And with this, I thank you very much for giving me this opportunity.
This is really good. I was actually taking some set of notes here, which is, I would say, a jargonaut of acronyms for sure when it comes to starting with prosumers, and then I like the vector way of looking at many to many here. So thank you. Let me actually move on to presentation, and certainly I want to have some time at the end to really have a discussion on some of the feasibility analysis here that we are looking at. Let me move on to the thematic presentation. Vishwajeet Singh, if you can really, please see if you can stick to. Yes, let's try to have discussion more than presentations here. So this will be good.
So what I will do, in continuation to what Soonee sir mentioned, I'll actually talk about some facts. I'll present some of the different models of VPP which we have deployed as a solution provider. So I had all these bunch of slides which I wanted to cover today. But let me start with, I think one of the topics here is about VPP business model. What does it mean when you talk about different kind of assets? What are those business models? How do these different stakeholders benefit from it? So giving you a very broad category here, if you look at the category under blue color, so here we are talking about a DISCOM, a utility, which has end customers who are residential and CNI, who have air conditioning load, thermostats, HVAC at CNI site, smart buildings. So what do they do with it? They actually connect and manage this load behaviorally or directly in an automated manner. They aggregate this into form of megawatt, and these utilities use this megawatt in different ways. And this comes to the business model which you're talking about. What are the value streams? So as a utility, for example, in case of CLP, China Light and Power, they're running one of the largest DR program in world with 9 lakh customers participating, almost 400 megawatt of load shed registered. The regulator is compensating them for capex deferral. So whatever their capex expenditure is, their capex is, a percentage of that is being rewarded to them when they are able to realize a load shed in megawatt. Then another model, CPS. CPS is another utility in the state of Texas. They have a demand response of capacity 240 megawatt. They use this capacity to service emergency situations in grid. You might have heard about Texas windstorms. They use this capacity to offset their wholesale energy costs. They use this capacity to offset their T&D deferral cost as well. And I can't share a customer proprietary information, but they have earned benefits in terms of millions. So this is how a utility can look at VPP. And trust me, demand response, any DER, it all comes down to how you're managing these assets. How do you driving value from megawatt? Ultimately, it comes to connecting and managing these devices, these assets, be it what Soonee sir mentioned, cross-border, be it large-scale wind, solar. For example, in case of Total, they have assets in France, Spain, hydro, wind, solar, battery. And what are we doing? We are presenting one unified view across these breadth of assets. They're using it in, so one of their battery, a large 100 megawatt hour battery, is participating in FCR market in France, which captures around 10% of the market value. Then the assets such as wind, solar, and hydro, they're getting an aggregated view, and they're trading in a day-ahead market, these assets. Remember, these assets may be in a long-term PPA. So this is what in India happens. Generally, we think of large assets, long-term PPAs, SECI tenders done. But no, this is how these markets are looking at these assets. Beyond these long-term PPAs, there are times in the day when these assets can generate much more value. They can go for day-ahead, they can go for intraday, they can go for ancillary services. So these kinds of value streams, of course, the market construct needs to support it. So when I'm talking about these markets, they all have provisions where VPPs are allowed to participate in ancillary market, energy market, and capacity market. And there are funding, there are regulations which are kept on, they're iterating it in order to support the VPP participants in the market. Another example is the segment around retailers and energy as a service providers. So a typical use case would be Shell Energy Australia, where they're managing hundreds of commercial supermarkets and refrigeration sites. They're using this load. Now, when we think of DER, to us, it's like solar, battery, wind. It's not like that. Any DER asset which can absorb or give out energy is a DER asset. So what they're doing is that they're managing the load across these bunch of sites, managing a demand response of more than 100 megawatt. They're trading it in ancillary services. Can you imagine? Demand response capacity is being used to manage your frequency. And there are regulations, and they're earning revenue from it. Then another use case is for green structure. What they do? They deploy small-scale microgrids. What is the benefit there? The benefit is not just limited to a commercial or an industrial customer where you get into a contract with them, provide energy as an energy supplier. You get into an energy contract. What they are allowed to do as per the market rules, and of course, you need to engage with the customer, that you are allowed to use those assets beyond the fixed contracts. So they aggregate the capacity across these multiple microgrid sites, and they use that for grid services. So what happens? The value which they are getting from this additional monetization, this also percolates down to the end customer. So this is how these business models are working, where everyone, whether it's the aggregator, whether it's the end customer, they're in a win-win situation. And the underlying technology which we talked about is an energy management system, an intelligent energy management system which can run optimization to drive this additional value which we're talking about, the megawatts which is needed, whenever it is needed for. And the whole concept of virtual power plant is whenever you need a dispatch grid megawatt, it is called for and it is available. And that's what an intelligent energy management system would do. And I think one of the most innovative use case I would like to share is Zoom. Zoom is a transport as a service provider. They are electrifying school buses in the state of California. The mandate given to them is replace all, buses, EV buses, with EV buses, and then on the grid side, what they're looking towards is that they want to aggregate a capacity of 1 gigawatt, 1,000 megawatt capacity in next 5 years with this deployment. And that capacity would be used to serve grid services and also, go for V2G use cases where you're ensuring the megawatts to be given back to the grid. And the interesting part is, one would think that how do you do with EVs? EV itself is a battery on wheels. And in case of EV fleets, whether it's a commercial fleet or whether it's the cab aggregators as well, there is a predictable schedule. So based on that predictable schedule, you know when this vehicle would be available for charge and discharge. So based on those use cases, based on those forecasting, advanced forecasting and schedule, people are looking towards monetizing these assets. Every drop of megawatt, they're looking at aggregating it and monetizing it. I mean, a question comes to mind, why do we get into this complex mechanism, right? Why don't we just install big batteries and solar power plants and wind and be happy with it? That is the mindset which needs to change. The thinking has been, it's always generation following load, rather than load following the generation. And I think Mr. Ghanshyam Prasad also mentioned about the prosumer. I think we overlook the trend that with this new segment of customers who are not just taker, but also giver to the grid. I mean, this is how the control room needs to come to the end consumer. And that integration needs to happen where an aggregator play a role in terms of managing these assets in a much more effective way, and the utilization can be much better. Then in the last, I think I would end with this one last slide which is on what do we look at on the ground? What are the ground rules which need to be set in terms of policy? In terms of policy intervention, I think with any use case, it needs to be financially viable, right? So in terms of that, there should be a model which appropriately compensates every participant in this entire equation. Be it the end customer who needs to have incentive. Remember, the VPP programs should always be designed around the customer preferences and customer choices. So the end customer needs to be compensated, incentivized, so that they're always ready, allow you to use these assets. Secondly, the aggregator needs to have additional revenue streams in the terms of market. The market needs to open up for various energy capacity ancillary streams so that they are allowed to generate that additional revenue streams. We need to, this discussion of how do we look at tariff rates is an ongoing thing. We need to look at how do you compensate based on dynamic rates. Second thing is, in order to make this VPP work, interoperability and open protocols is the way to go. We need to abide by open standards if we really want to control any kind of assets. So anything around open ADR, IEEE, SCADA, we need to, these open standards need to be part of specifications when we are talking about energy efficiency. So right from smart ACs to EV chargers to inverters, right? We have a target of deploying 10 million rooftop solar panels. So these devices, these OEM needs to follow a standard protocol so that in future, the technology lock-in is not there and an aggregator can actually have a viable business model and also an easy entry to the market. So the entry barrier should be reduced. And the third one is the DER penetration, which is happening at a localized level, at a substation level, that needs to be accounted for in the integrated resource planning for a DISCOM. So you should look at what is the penetration of DER, which looks like in next 5 years, and then you can plan your non-viable alternatives. Then you can look at what is the capex you would be planning for next 5 years and versus what is the DER which is coming in. How do you balance these out so that your capex costs come down? And last but not least, the market should open up avenues for everyone in this space so that people have the courage to go ahead and do these innovative business models. Otherwise, if there is no end value in terms of real money, this would just be limited to pilots. And I would just end by saying that I think what is the way to go? The way out is design programs, get central government funding for these new VPP programs, involve participants, industry, DISCOMs, any asset owner, have policies on the ground, and run VPP trials for at least next 2 to 3 years. Then only you will be able to understand the value And how do you reiterate those policies? How do you reiterate those business models in order to get a policy on the ground? That's all.
Thank you. Thank you very much, Vishwajeet. Great incentives, great insights across the gamut of topics that we're going to talk. Really appreciate it. Let me move on to the next one. I'll actually follow the order in this because that gives a very good mix of utilities and then solution providers talking about it. So, Abhishek, if you don't mind, please give your quick comments. Again, 7 minutes. I'm actually timing it here. Just want to give you a heads up here.
My best regards to all the dignitaries, ladies and gentlemen. Myself Abhishek from BACH Power Limited. From utility perspective, I will discuss the VPP, what are the challenges and how we can go ahead in this regard. So when we talk about VPPs, we would have to see the DERs first. Although all the things that VPP contains has been discussed over here by many distinguished speakers, but I would like to mention something that how a VPP model can be in actual condition maybe programmed or maybe utilized in the actual scenario. In DERs, we have basically 3 stems. One is distributed generation resources. It may be wind, it may be solar, it may be any distributed tidal energy or anything. Second thing is storage. Storage is taking boom now. And third thing is demand side management. Even if I am not able to include any renewable energy, and if I am cutting some secondarily preferable load, then naturally I am supporting the grid. So we have these 3 things: demand side management, distribution generation, and distributed storages. But where we are lagging now, we are lagging on observability and controllability. We can't observe how much storage is available at some particular location, and we can't control it. That's why there is a need of VPP, virtual power plant. In this slide, you can see there are some conventional things. We have power grids, transmission lines, and then load, household, industrial, and commercial load. Now the things that are being added are wind power, electrical vehicles, solar power, and residential fuel cells, batteries, energy storage systems. Then you can see like all these things that are being added now, they have small capacities, they have n number of the items, a lot of the numbers they are. That's why till date controlling and observability has not been established till now. But now, as you can see in the real scenario, like in BSCS, we have connected 6,200 solar distributed generation resources to our grid. We have added 163 megawatt, and the numbers are increasing rapidly. Thanks to the initiatives of the government, like people are getting motivated and people are coming to the grid, consumers are becoming prosumers rapidly. So this is the time like we should start now. And how we should start, we can see like all the, among these technologies, wind power, solar, battery, electric vehicle, all these things are governed by power, but they have different technologies, different characteristics. But due to their power things, so they have something in common that we have to grab. Every system has 4 things. That is active power, naturally. Active power, that is actually required to run a load. We have reactive power to maintain the voltages. We have energy requirement particular for customer, and we have transfer capacity. So we will talk about all these 4 things, and then we will make a model in very short span of time. We have active power modulation. Any unit, it may be solar, it may be battery, it may be anything that is connected to our system. It have a limit to the active power. That is maximum active power that it can provide. It has a duration for how much time it can give the active power, that shall be energy, and the ramp rate, how much quickly it can add to our system, or how much quickly it can absorb the active power. Negative values for storage, naturally, positive values for generations. These 3 values we have discussed, the amount, the duration, and the rate for active power. And 2 things for reactive power. The amount of reactive power that somebody can generate or absorb, and the rate of reactive power. Now we have 5 things in mind. Anything shall have 5 things. Active power 3 things, related to active power 3 things, related to reactive power 2 things. And when we plot it in vector diagram, when we go for active power, we can have a block, square, 2D. And because there are 2 dimensions, 2 items. When we go for active power, there are 3 dimensions. The amount, the energy duration, and the rate. And this modeling can be done for anything. It may be 2 kilowatt or 200 kilowatt or 2 megawatt. This thing can be made for anything. And when there are a number of multiple installations, it may be 6,000 and 6 million. We have the data of each and every by the data sheet, and we make a group of the installations. Like in this scene, you can see CCP1, common connection point 1, common connection point 2. In common connection point 1, CCP1, we have added, you assume 5,000 customers, 5,000 installations we have added. We know the blocks, the capacities of individual, and we add them. Then we see in the right below blocks, there is an available flexibility volume. How much energy is active power based on active power is available, and how much energy based on reactive power is available for that complete cluster. Naturally, for a grid operator, it is not possible to touch each and every point for 6,000 or 6 million points. But it is easy rather to touch only 10 points or 20 points. So if we divide all those solar installations in some few numbers, make a cluster. For wind, make a cluster. For battery, make a cluster. And make the flexibility volume in this shape. We know the load is very much based on the customer. We don't have any control on that. But we do have one thing, we can do the forecast the load. So based on the load forecasting, if I know like in the evening 5, my load is going to come, then keep my battery bank in the storage, and as soon as the time shall come, I shall be ready based on this graph, needed flexibility and available flexibility volume. And when we are doing in this way, we have to have some things in mind. The solution should be very cost effective, because the customers are of only 2 kilowatt, maybe of 2 kilowatt or 2,000 kilowatt, but the solution should be cost effective. We should have a modeling for which type of customers should become on the same in one basket. They have different baskets, storage shall be in one basket, or whatever the modeling shall be. We have to work on that. Then the communication method. Thanks again to Government of India policies like smart metering has been implemented and is going to be implemented further. By smart metering, this communication shall be possible. No extra money have to be invested, and this smart metering shall help to us for observability and controllability both. Distribution automation is also going on. Utilities are doing, startups are coming, utilities are doing pilots based on distribution automation. We are also doing that in our network. So distribution automation shall also help to have the observability and controllability. All the data shall be available to system operator in real time. And yes, there is a challenge as well. When you have multiple of technologies, there should be a same language. Wind, the technology that is being used in wind power for communication, it should be the same for solar power, so that the operator shall have single language to all the things. As sir said, like we should have a standard communication methodology to attain for all these communications. This is for me.
It's on. Okay. Yeah, thanks for sticking to the time. 7.5 minutes, by the way. Let's move on to the next one. Ankur Sharma, founder and CEO of Flock Energy, please. Yeah.
Good afternoon, everyone. Firstly, thank you so much, Reggie and ICF team for the invitation. Really glad to be here. Now, I would try to tackle this topic from a slightly different angle from how a startup thinks or how the startups that are coming up in this space are thinking about it. A lot has already been said about technology, the readiness, and we can do hell of modeling and we can do everything that is to be done from the technology side of things. But are we approaching this from the right standpoint is the question that we have been as Flock Energy thinking about. So we started our journey 18 months back in London. We do, just like every other company, we started doing desk research, we started modeling, we did our business models, and we did a number of other things. And all the research pointed to the direction that India does need a technology like virtual power plant. But 6 months down the line when we took the flight and came to Delhi and spoke with discoms and other people in the energy ecosystem, we understood, and the constant feedback that we were getting was probably we are 3 to 5 years ahead of time. And that's a harsh reality. So that's the difference between what we theoretically say is possible and what on the ground is actually doable. So thinking around the building blocks that we should be thinking about in order to build this virtual power plant, in order to scale virtual power plants, the first thing that was mentioned by Mr. Soonee was trust, billing and settlement. So that was the first lesson that as a company we received once we landed in India, and that was from my father himself. So we were building a hardware plus software solution that could identify where the flexibility lies in industrial settings. So whether your machine is 80% flexible or 20% flexible, that is one of the key building blocks that should play a critical role when we are designing virtual power plants. So I went to my dad, I said that this is a solution that we have built. We are working on a no-win, no-fee model. So would you be interested in trying this out? So the solution that it entirely did was it would tell you how much percentage of time your machine is idling. So it was a smart meter, it was a high sampling meter that was connected to CTs, and then we do machine learning and AI to identify what's the idle time for a particular machine. My dad said, why not? But 1 month down the line, when you come and you tell me that this is the amount of savings that we have done for you, all I'm going to tell you is that this is the consumption that I have decreased, not the savings that you have made. Similarly, virtual power plant and demand response, all of these things need the customer's buy-in, needs the trust to be built with the customer. And that's something which probably we need to first start building. We have seen the examples of smart meter adoption. Customers are saying that their bills would be increased if they deploy smart meters. We have seen examples of how a technology, so the point is directly copy-pasting the technology is not going to solve Indianized version of problems. Another example beautiful example that was shared by Mr. Sanjay Banga yesterday was one of the companies came to him and said that we would be able to do disaggregation at an equipment level, and we would be able to tell you whether this household needs 2 more AC. This data can then be sent to Chroma and other companies, other OEMs, so that they can install 2 more ACs in that household. He said that that's not the need of the hour. The need of the hour for him is to understand which customers might be more likely to perform theft. So he was willing to take that data, but he was going to Indianize that technology and that data and solve for some of the problems that are more critical. Similarly, another building block that is extremely critical for us and for what we identified was not in place was forecasting. So during discussions with Discom, we understood that demand-side forecasting as a tool is hardly available with even the most advanced Discoms. So when we don't know what the demand is going to be, when we are not even at that stage where we can understand how the customer demand is going to behave, why are we even thinking about virtual power plants? I mean, it's good to think about it, but I think we should focus on these building blocks first and putting these technologies in place so that once, as and when we have virtual power plants and deploy virtual power plants, we are in a better place to scale them and not fall flat on our face. Yeah, so Mr. Respected Chair also mentioned that it's a customer-facing solution. It's not a solution that is just going to be a technological solution that we deploy and does not require the customer to participate. Because of the active participation from the customer side, how do we take the customer buy-in is another building block that we really need to think about. And I think in that regards, Indian dynamics are way too different. So as we all know, women are the main household keeper, and they kind of take care of all the things that are going on in a household at a household level. It can be electricity, it can be gas, it can be all the other utilities that we are utilizing. So is there a way for us to think out of the box and understand whether women as the key household player is going to play a critical role in this demand response and virtual power plant structuring or not? And that's something also that's like sort of out of the box thinking that startup like ours need to do and come up with some of the innovative ideas that are to be explored. And lastly, I think we need to also engage ourselves in a mindset change. We have been mostly following the technologies that have been tested out in UK, US, and virtual power plants happens to be another such technology. So are we going to be in this same mindset that whatever technology is being developed outside, we just simply copy-paste that and apply it in India? We have seen previously technologies have failed, such as GIS at a DISCOM level, which was rolled out in 2002. But are we going to do the same mistakes, or do we really need to think deeply about what we need to build and how we need to build it? So that would be my final comment, and thank you so much again for the time.
Appreciate. Let's actually hear one more of solution providers here. Meenakshi, Vashist, co-founder and CEO of TekUncorked. If you can probably give your remarks, that will be great here.
Thank you, Reggie. Thank you, ISDF, for inviting me for this forum. And TekUncorked has been, I think some of the, my esteemed panel members have brought out some of the aspects on the virtual power plants. And one of the underlying things, which is coming about as I'm, hearing people speak, is that what you need is a platform, a smart distribution grid, or I would say a VPP kind of a management system which allows integration of not only the grid but also the various DRs and the DRs into the system. So I'll just go down and look a little bit more closely on some of those things and how for India that is something that can be enabled. Okay, so let's look at, typically when we are talking about power generation all the way to distribution, how has it been handled? We have power generators, it goes through long distance transmission, and then you distribute it to the end consumers. Okay, now where does VPP figure into this? Okay, what are we talking about when we are talking about DERs, or the distributed energy resources? So in the traditional model, we have one kind of power generators, which then goes through a traditional model of, the 33 kV being stepped down to 11 and 11 kV, then again to 0.4 kV, and then it finally getting distributed to the consumers. The moment we are talking about the emerging technologies, and we start talking about rooftop solar, and a load which is continuously moving in the form of EVs. EVs are on the road, and then they need to get charged, and this is a mobile load. This immediately gives you a totally different kind of a scenario. Now, one thing is that the solar plants or the rooftop solars are just locally, taking care of the consumers. The EV infrastructure you would continue as there are more and more EVs on the roads. The realistic scenario would be that there would be charging stations which would not have enough electricity for charging those EVs. And, things which are right now, I would say everything, whether it is the EVs or the rooftop solars, which are more in a pilot stage, slightly larger size pilot stage. If we really want, you're talking about a country which is over 3 million square kilometers. And if we really need a wide-scale proliferation, then, things have to work differently. And that is where this whole integration and the concept of VPPs comes in. Oh, I think I'm going to. Okay, so let's really look at, what are the key challenges which come in as we talk about VPPs. The first good thing is when we talk about virtual power plants, what we are talking about is resource adequacy at a low cost. So I have all these, distributed energy resources spread around, and if there is a way to forecast the demand and manage the load and dynamically intermix the different kind of power sources, immediately we are talking about achieving tremendous amount of load shedding and achieving resource adequacy without the need of putting too much of capex on that additional capacity generation, because what we are doing is that we are leveraging everything which is existing all around. So what is it that would make it possible? The first thing that is required, that wherever we have distributed energy resources, whether this is rooftop solar, the battery storage, what we need to do is the mechanisms or the hardwares which ideally would be some kind of IoT systems which are monitoring the load at a sub 30-minute level, okay, at a very high performance level. The second thing is it is able to, by curating that load trends, can really come up with very, very smart ways of forecasting demand, the long-term demand, the mid-term demand, and a sub 30-minute demand. And the third thing is the security and the power quality. Are there rogue interventions which are happening in the network, okay, which can really get a big section of the city, going down because there is a rogue intervention coming in. Also, the power quality. You do not want to have, substandard power quality coming in and being injected through these DERs. So I think all those things become very critical, and what will really, manage across all these issues and challenges, which basically the concept of DER integration brings in, is a single layer of intelligence which does two things. One thing is that it's a layer of intelligence which is sitting on top of the distribution grid and first managing the energy access there itself. We have electricity being lost in the distribution grid. So how do you make the grid much more robust, more efficient, and more resilient? And the second thing is, how do you smartly intermix the different kind of energy sources which are coming in? So this is a typical example that this is, traditionally, this is a load curve which looks like the moment you start mixing in, what it means is now there are, and this is something which needs to be managed through intelligent software and a software single platform, which is actually, talking to all these different resources. So 8 a.m. onwards, solar starts taking off, and there is a part of the load which can be furnished through that. The batteries which had drained out from the previous night, you start getting charged through the solar, and somewhere around 11, 11:30, 12 is where some part of this load can be shared by the batteries, and that is where a very, very smart and fine level of balance is required, and that can be achieved only if you have systems monitoring both the demand side as well as the load side, and looking at each and every DER and is managing the way that the whole distribution would take place. And the DRs come in where you say, in a very structured manner, how do I really say, okay, some of the non-critical load can be staggered across the day to shave off the peaks. Okay, so I think, again, emphasizing again and again, single platform, sitting over the distribution grid management, integrating the DRs, and the DRs is actually going to transition VPPs from the pilot phase to a large state proliferation. I think that's pretty much from my side. Thank you.
Thank you. So let's look at the other side of the equation. Devanand Pallikuth, I think Chief PSCC Tech Services, Tata Power Company Limited, hopefully will get one more perspective from the utility side if possible.
Yeah. So, good afternoon and all the panel members. And before I start, I think I had prepared all the PPTs with a thought process of building in the flexibility. And very interestingly, we in Mumbai handle both the flexibilities. When I say both the flexibilities, one side the distribution part, which we are talking about, how we manage the power and system. The resource adequacy in terms of power. And the other part of the flexibility is what I think Soonee Saab would be very much happy about, that is the transmission flexibility, or say handling the transmission problem, right, which is a very critical one. And when we talk about Mumbai, we talk about islanding, right? Anyway, so, but looking into what I think all my co-panelists have been talking, the two things which I would just like to add. See, point one is that when we are looking into flexibility, and I really am very happy that my conscience is in the same line as Honorable Chairman has said, that the whole success of smart grid is when we bring the consumer in our action, right? The whole power system has been running along on a monotonous or monologue. The way we bring the dialogue in or the consumer in is something very, very important. And VPP or such orchestrations does help, because what we are trying to bring in is basically bring in all the actors who are going to contribute to the security of the system. Now, I will not run through all the slides, but there are two critical things which we as a utility had tried out, so that we are ready for the next step as and when the system comes in. Because one is how much step you are going to take and how much readiness you are taking. See, I'll give you another example. I think in the morning when Dr. Das was discussing on the demand response. Now, that was a time when demand response was basically not so much of a used term in India, right? So what we did combine this demand response along with smart meters to bring the pilot, right? So that we could travel. And again, it was only taken as a alternate to load shedding to that extent, right? But one thing which we gained out of was that how it could be envisaged into the system. Same way, what we have done in our distribution management, we are developing platforms. Platforms which are in-house platforms, the platforms which can enable a consumer, or say you can say a simple prosumer, a single, say 1 kilowatt consumer to a large discom to manage their power systems, power management. I am talking about power management, not systems. I am saying how he is going to bring in whatever resources he has got to a complete common base where he can actually interchange these information or data with the consumer, with the utility, right? Or how he wants to do. And as we develop more and more platforms, and as regulations enable these platforms to come, that platforms could be used by these users, the power users, to actually manage their system. I'll just show the small part of it which we do for the discom, right? So this is something which we do for the discom. As you can see, there is an integration of rooftop solar as well as EVs, which has also been put in, along with the forecasting and optimization with the conventional sources. Now, this is a platform which is being used by the discom, but as we grow along, this would be available for even the sub-consumers which are there. The other part which I would like to share, which is a fairly new thing, is as we had done this peer-to-peer pilot at Dandi. In Mumbai, we do have a different challenge, that our rooftops are not that much, right? So the scope of peer-to-peer from that perspective goes in. But if you look into it, we have got high number of open access consumers who are having green power. Now these are consumers, because of certain limitation in regulations, they have to forego their excess power which has been generated more than their schedule, depending upon how the whole thing comes to the discom, where they don't gain value. So we created this platform using blockchain wherein he could trade off his surplus power. The scheduled power, again please understand it's not the generated power, I'm talking about the scheduled power, where adjustment happens between the DISCOM as it is happening regularly. However, the differential is paid based on whether he is actually surplus or shortage after the month. Now, this is also very critical because as Soonee sir was saying, creating a platform where these players in the whole system can also trade off their surpluses or shortages. Now, this is very important because to avoid the surplus not to be let off into the grid at less price, the consumers generally don't tie up for the maximum level which they want. For example, if he has got a plan to go 80% because he knows that if I plan for 80%, at certain time of the year I may be surplus, so he generally ties up for 40%, which is a sub-utilization for his own level. Plus, there could be a possibility because, I mean, as a utility you are charging that extra charges for green power, the same thing can be utilized here. Anyway, so I think the fundamental part as far as these two solutions which we are saying is how as a utility we get adapted to all these things. And this is very, very important. Possibly I'll just put up a question mark here where we are saying that I would say this 100 kilowatt and above regulation which has come, but we are not finding much of traction down the line happening. It is only because the DISCOM is finding it difficult how we manage those things. And unless until we do have systems and platforms in place like this, we will have a difficulty. That's it. I think, thank you very much, sir.
Not the least presenter here, Arindam, who is going to give a perspective from a solution provider side, and then we'll probably open up for a few questions after his presentation.
So the good thing being last is everyone has talked all the points that you wanted to say. So you just have to sit back and relax. So again, thank you. So what I will do, again, being last, I will probably take the privilege to summarize the key points. So the first point, Mr. Singh, Vishwajeet Singh, you mentioned that moving forward, we are moving into this paradigm of load following generation. The second point that you also mentioned, right now, VPP discussion and incorporation in planning is non-existent. The third point, our Mr. Honorable Chair, you mentioned about this concept of prosumers. You are buying and you are selling, and you have to get paid. Then you guys mentioned about dynamic rates. It's still wishy-washy, but it's needed. And then Mr. Abhishek, by the way, your presentation was rock solid. You mentioned about observability and controllability. Right now, we do not observe, period. We do control, but we control at the local level. Now, the utilities will come and tell me, who told you that? We also observe at the enterprise level. But in US, we have no visibility. Utilities do not have absolutely no visibility in behind the meters assets, zero. That is why there is a struggle of this VPP. We have been talking about VPP and DERMS for the last 1 decade. And the reason why this has not happened, even in US, is because they don't know what they are seeing. And then your last point was the utility adoptability. What is that size? I think that's the crux, and just like you, even though I'm from L&T, but my background is with EPRI and utilities. So we as engineers always make one mistake, especially people, OEMs like me, like L&T. We try to design a solution first, but we do not understand or we cannot explain to people what is the problem we are trying to solve. So in USA, and this will going to happen even in here also, we have seen this duck curve, as the renewables are growing. And what has happened is, as more and more renewables grow, the duck's belly keeps going down. It becomes a canyon curve. That's a problem. And this is something, this is the latest data from Cal ISO, okay, from 2023. So, again, this is something, Abhishek, you already mentioned, sorry. But I'm going to make one thing, at least in USA, and this is something Murali and I have been working. Whenever we talk about flexibility, we talk it in terms of flexible interconnection. So that we have the way that you can control with different schemes. That's in essence your 5 vectors that you are talking about, 3 for P and 2 for Q. We don't do that in planning in any of the utilities today. So what is happening is, every utility in US is mandated to do integrated capacity planning at a snapshot level. There is no snapshot level VPP benefit in the world. You have to do this way of kind of evolving how your capacity will change, on a time scale. That's what you guys are talking about. But then the question is, we have to prove it. We have to take the data from the utilities and we have to prove on a feeder where they are using hosting capacity a static number. If I have an ability to go up and down, I am actually doing a capacity deferral by X years. You have to have a non-wires alternative discussion in this mix. You develop business model not in isolation. You develop business model based on the problem that you have. And just like NREL, several utilities are now trying to figure out this process of flexible interconnection and implement them in the planning stage. Now, why is this new, right? I mean, several years ago, NREL, EPRI, we used to have these DERMS, right? We used to have a local controller, we used to call DERMS. We used to have an aggregate controller, we used to call DERMS. We used to have an enterprise level controller, we used to call DERMS. So is DERMS different from VPP? That's a question that I want to ask everyone. In my opinion, it is not. It's just a fancy way to say virtual power plant. And I think, and this is where I guess we probably need to not get hung up on the definition. What we are trying to do, just like what you guys are saying, we need to, since load is now following the generation, we need to incentivize the consumer, and that will help the utility, right? So if I look at, and again, this is a source coming from the work that NREL and DOE did. If you look, one of you guys said VPP came into existence in 2000. No, VPP came into existence 10 years after I was born. And that time they were doing, VPP basically for an emergency use demand response. And then as you see, just like Abhishek you were saying, right, the energy and capacity and ancillary service. Tough to do ancillary service, but energy capacity, see that's where we are all heading. You also put the point where it is not just DER, meaning PV, wind. Look at all the loads that we are talking about. When we started this journey, it was all about heat pump, water heaters, air conditioners, and whatnot. I think I've run out of time. But again, most of the market analysis that people do, they are all wrong. But there is one point I will make. Whether you call it VPP or whether you call it DERMS, this is not going away. Why? Come to the problem. Because of two massive loads that will come into the utilities, electrification and server loads. So when you have that amount, and you cannot build new transmission lines fast, and your renewables are intermittent, something has to be controlled. And the only way to control it is to provide these incentives with the consumer. I think that's it. I will leave it there. Thank you.
Thank you very much, Arindam. And I'll really appreciate all the panelists being on time. I mean, you guys did great. I wasn't interrupting you, hopefully, but you guys did great. Again, I can sit here, summarize the whole thing. I really want to open up for a question or two, but let me say a few things that I kind of observed. I did hear blockchain and ledgering techniques. I think these are enablers for some of the future trading of it and transacting systems. I think that's one more thing. One more point, I don't know if that came across, but really a food for thought is, yes, there are solutions, yes, there are needs, but where is the tipping point? I think one thing which we are looking more broadly is, I mean, again, wearing my renewable energy hat, right? Does 20% renewables needs this, or does 80% renewables need this? Certainly 80%, yes, we need to use all possible flexibility in the system, whether it's coming from big resources or behind the meter resources. And it's inevitable that you have to squeeze it in to make the system as economical as possible. That's one thing I want to think about. And again, it changes with system to system, but that's something that I thought is really important to look at when it comes to the tipping point of these kind of technologies. Before I hand it over to the chair here, I think we do have 4 minutes. I want to open it up for one question in the audience. Any budging questions for the panelists here? Oh.
I'm Rajan Varshni from NTPC. In all the presentations, whatever technologies have been shown, like PV, wind, and with the battery also you can make it stable, but with the concentrated solar power and thermal storage, you can make it firm and dispatchable, and it is least cost also. But I didn't find any mention of these technologies here. Although these discussions came near that, but eluded that. Solar means PV as well as thermal also.
Yeah.
I tried to answer this, but I did it very carefully, because otherwise chair will kick me out of the podium. So again, as I said, you are solving a problem. There are multiple solutions. Just to your point, if I put a battery and make a variable resource to dispatchable resource, have I solved it? Answer is yes. But at what penetration level? But as you start increasing, because right now there is no problem. There is no virtual power plant in the way we are all talking in US, in any of the utilities that they have implemented. Now they have implemented ADMS, they have implemented enterprise level variations of DERMS, but there is no enterprise level version of VPP, because it's not needed today. Will it be needed in future? Answer is yes. Because when, and it is not just the PV or wind, when you have that much electrification load spread across, whether it's a transit, fleet, public vehicles, the demand will go haywire. I mean, you will have heat maps of all the feeders where you might have a problem. That's when the utility needs it. That's why Mr. Chair is saying we are in the position where we have to do something. That's all.
Yeah, one thing I'll also add is economics plays a significant role, because I saw you comparing 3 different technologies here. Again, I'm sure there is a session tomorrow more on storage, which will shed more light into different technologies. I think here we are more looking at how to tap into flexibility, and sure, there are options to tapping into flexibility and what makes economical sense given the time scales and duration. I think that's what will win in an equation like that. With that, I'll pass it on to our Honorable Chair, Ghanshyam Prasad, to really wrap it up and provide his comments. Thank you.
Thank you. I think you have moderated the session quite well. And as I mentioned in the beginning, I think this is, though it looks to be new, and that is how it attracts everybody where the topic as a virtual power plant. But I think what it ended was, is it really a virtual power plant, or what we had already been doing as a part of our system altogether? I think I can't answer you just now, but definitely we are trying to pack up in a new bottle.
Uh, of course, the good thing that has come out today, and which definitely I get enriched by the idea, is the involvement of the utility. Can it be through the market, demand response, and allow assets beyond contract? I think this is the key which was suggested by Vishwajeet. I think assets beyond contract, what we have also realized in India, and what we found is it's a contract between the buyer and seller which is binding, and through which we are not able to optimally use the resources, even though it is surplus to some and deficit to somebody else. So we have already changed this construct by way of rules. Rules have already been notified. So which enables anybody who has a surplus power, the generators, or even the buyer, both sides. That means from the resource as well as from the demand side, they are all free to go and sell into the market. That means if resource gets unbound and has no binding from the agreement point of view. And this is probably what we are talking from the VPP perspective, wherein we want any kind of surplus, whether it is available with the generators, it is available with the discoms, available with the captive consumers, or the prosumers, what I was talking about. Vehicle to grid definitely is a good concept. In fact, we had also, just 3 days back only, we had interacted with the California utilities and California commissions, etc. And we had a good 2 hours discussion in Ministry of Power, wherein some of the solution which was suggested and which they are also going to try in California, probably that is workable, and probably we can think of happening that, particularly in some segments like school buses and all. And where there is a predictability, I'll come back to that aspects once again. What so far, I think this point has been highlighted, and I also spoke initially, that is, so far we had unidirectional flow, that is generator, transmission, distribution, and then consumers. Why not the other way around? And that is what is the need of the hour. And coming from the monologue to dialogues and multi-logs probably, that will be the construct that will be going ahead. It was talked about the incentives, end consumer incentives and additional revenue. These are the 2 things which was also pointed out. And I'll just put across that I think one of you also spoke about the initiative that has been taken by Government of India under the Surya Ghar Yojana. And Surya Ghar addresses both of them. That is, government is providing some incentive and also trying to ensure that anybody who has surplus power, surplus electricity, even through this scheme, that will be bought by the discoms. That means they will be able to earn additional revenue. Virtual power plant as a part of integrated resource planning. This is again, I think all of you have highlighted this, and I think the time is coming that we need to really integrate it as one of the element. But probably right now the quantum is very small in this particular kitty, and particularly in a large grid like India, at least not at a national level. But definitely it will be good to have it at the distribution level and in local area sort of things. Probably that will be a right choice to go for initially. And once it takes off, and maybe if the quantum becomes larger, probably that can be considered at a discom level, then going to the state level and further and further. What Mr. Soonee also mentioned is definitely I echo with his sentiment because so far we are running a very, very large grid, and it is one of the largest grid in the world, which has its own challenges now. And we can't afford to have any kind of mismanagement which will lead to huge amount of disruptions. So another challenge that is being thrown to the grid operators, if I look at from the grid operators point of view, so far they had been very comfortable managing almost predictable type of generations, whether it was thermal, coal, gas, or hydro, or nuclear, all these are quite predictable in nature. Of course, there had been forced outages, untimely outages, which they had been handling so far. But with the introduction of solar, wind, etc., definitely the variation has increased. And if I increase this variation to further many-fold, because now what we are targeting is a smaller numbers, and these smaller numbers will be happening at the consumer's level. So either we introduce some kind of a concept of an aggregator. Of course, the concept of aggregator has already been introduced in the electricity grid code as a QCA, who will be integrating and trying to play that kind of a role. Maybe that or slightly at a larger size can try to help this kind of, and that probably will take care of one to many or many to many or that kind of a collective transaction construct. So what comes to my mind is, right now as a grid operation, we have two tiers almost. That means state load dispatch centers, and then we have regional load dispatch centers, mainly playing the role to control the national grid. Maybe later on we'll have to have a smaller size control areas. Of course, there are ALDCs, area load dispatch centers, in some of the larger DISCOMs, but probably we'll have to go and look at a consumer-based type of sort of things, wherein these kind of things can start percolating. Controllability and observability definitely was pointed out by Vashist, I think, BSCS. One thing that comes is regarding when we are thinking of making it as a resource, that means what we are trying to do it, we are trying to put it in a modeling exercise. Normally, modeling and practicality, these two things one has to be very, very careful. I can model it, and generally model helps me in applying my resources, what I am going to add in future. That means I am going to add solar or wind or battery energy storage or hydro PSP or coal or whatever it comes to. If I am trying to substitute it for a short-term measures with DERs or that kind of resources, I have to be very, very careful to what extent I can go, because of the voluntary nature of these resources. These are not compulsory in natures. Other resources are almost bound by certain rules, regulations, laws, wherein there is a predictability to the generators, to the buyers, and even to the grid operators. So that construct probably will have to build into this system as well, so that what Mr. Soonee was also mentioning, that we have to be very, very clear with respect to legal angle, to the regulatory angles, to scheduling, metering, billing, dispatch, etc., etc. So until these game or these rules are defined, probably it will have a larger implications on the DISCOMs and management of the DISCOMs to that extent. So what is needed to my understanding is, of course, whenever it is at a smaller scale, it can take off, absolutely no issues. But as it grows, probably we will have to grow and we will have to change the system, we will have to change the rules, we have to change everything so that it also gets as a part of the entire system. Flexibility definitely is required, and this also I had mentioned in yesterday also, that flexibility in terms of resources, transmission, distribution, or you talk of anything, because the moment you have introduced an element of uncertainty, definitely you need flexibility, and that is how I'll say with this new name or so-called growing area in the power sector, probably it's a new child that is getting born and which has to grow and grow as old as what others had contributed to the power sector. At the end, I'll just add only one more thing, that is, I think somebody talked about 100 kilowatt has not taken off. We have tried to introduce two concepts in this, and I think it has taken some time to push it forward, but I think with NOAR, that means National Open Access Registry, and trying to see that the registry works perfectly well, trying to integrate it with the SLDC as well, I think it is likely to take off as quickly as possible. We had also tried to see not only to the 100 kilowatt, virtually we have even given flexibility to even lower loads. And that load, what we have said there is, if within a circle or within an area of a discoms, if a smaller loads also combine together and aggregate to 100 kilowatt and above, they are also eligible for this open access type of things. Even the curtailment part, what has been said, and we have already tried to see that the surplus power starts getting traded into the market, and this we did it around 2 years back by way of, I think most of you must be aware about the must-run rule, wherein we said that all REs are must-run and they have to generate, but then we'll allow you any surpluses power, compensation or whatever you call it, if and only if you generate, sell into the market and get it compensated, not as a deemed generation. So that's a concept we have adopted and it has been very, very successful, and that is how, I mean, these surpluses at least have been able to get integrated into the system. Indian consumers are getting benefit of actual generation, not as a deemed concept. So I, as a person, have seen that we should not try to go again back to the deemed era. It is always better to have something which is already practically possible and physically available. Accounting has to be proper and things really work, and it has to be in the benefit of all the consumers. So these were some of my thoughts I thought I'll just share with you, but definitely VPP is going to be a reality very soon. But then when we are planning, we have to be very, very careful, because the reason why I'm saying is you must have enough resources to take care of any kind of uncertainty in the virtual segment. And the lesson learned is again coming from US. We had a California crisis, heavy dependence on DERs or demand side management. And if something happens, say for example, if hydro fails, if you have a dry season, where you cannot immediately build up a resource that will supplement that kind of a situation. So your resources should be such that it takes care of those kind of contingencies as well. Do plan, go ahead, but you must have enough backup. Thank you so much.
Thank you very much for a very good summary.
Thank you everyone for the insightful presentations and valuable contributions on virtual power plants and power system flexibility and business models. Now I would request Mr. Rezi Kumar Pillai on the dais to hand out the token of appreciation to all our speakers. Starting with Mr. Ghanshyam Prasad, Chairman, Central Electricity Authority. Next, Mr. Murali Baggu from NRL. Next, Mr. Vishwajeet Singh, Senior Manager, AutoGrid. Thank you. Next, Mr. S.K. Soonee, former CEO, Grid Controller of India. Next, Mr. Abhishek Vashistha, Deputy General Manager, BYPL. Next, Mr. Ankur Sharma, Founder and CEO, Folk Energy. Meenakshi, Vashist, Co-Founder and CEO, TekUncorked. Mr. Devanand, Pallikuth, Chief, Tata Power Company Limited. Mr. Arindam Maitra, Vice President, L&T Digital Energy Solutions. Thank you, sir. Now I would request all panelists to